Hello everyone. Let's have a look back in time. Before we begin, it will be a great help to us to create more and better content for you guys if you could just like and subscribe. Let's get right to it. After 25 years and over $10 billion on Christmas Day 2021, the James Webb Space Telescope was finally launched into space by a European Ariane 5 rocket. With its 6.5-meter primary mirror and its tennis court-sized sunshield, Webb had to be folded up to fit in the rocket's fairing, only to be deployed step by step in the first 2 weeks of its mission. On the 12th of July 2022, months of eager anticipation paid off, as NASA released the first full-color images of the cosmos captured by the James Webb Space Telescope. The latest JWST image is a wonderful view of the Cartwheel galaxy, a composite produced by the telescope's near-infrared camera and mid-infrared instrument. James Webb Space Telescope's latest image. The latest JWST image is a wonderful view of the Cartwheel galaxy, a composite produced by the telescope's near-infrared camera and mid-infrared instrument. James Webb Space Telescope image of the Cartwheel galaxy. The Cartwheel galaxy is the result of a collision between two different galaxies that took place about 400 million years ago. What remains is an inner ring and an outer ring, giving the galaxy merger the appearance of a spoked wheel. These spokes are actually the remnants of the arms of the larger galaxy, which have been distorted as a result of a collision with a smaller galaxy. The scene appears red through Webb's infrared view as a result of the glow from hydrocarbon-rich cosmic dust. Galaxy mergers are some of the most spectacular events in the cosmos and make for incredible images, as this JWST image shows. One day our own Milky Way galaxy will collide with the neighboring Andromeda galaxy, resulting in an event referred to as the Andromeda Milky Way collision. Images like this one captured by the Webb telescope perhaps give us an insight into the fate of our own galaxy's future. Webb telescope's Jupiter images. These images from JWST show Jupiter and its moon Europa, captured by the telescope's NIRCam instrument. Not long after the first JWST images were released on the 12th of July came these incredible images of the tempestuous gas giant planet and its intriguing moon. NIRCam's short wavelength filter reveals Jupiter's distinctive bands and famous Great Red Spot, a gigantic storm that's wider than planet Earth. A view of Jupiter, its moon Europa and the Great Red Spot. To the left of the Great Red Spot is Europa's Shadow. A view of Jupiter, its moon Europa and the Great Red Spot. To the left of the Great Red Spot is Europa's Shadow. Combined with the deep field images released the other day, these images of Jupiter demonstrate the full grasp of what Webb can observe. From the faintest, most distant observable galaxies to planets in our own cosmic backyard that you can see with the naked eye from your actual backyard, says Brian Holler, a scientist at the Space Telescope Science Institute in Baltimore, who helped plan these observations. To the left of the planet we can clearly see a black spot. This is Europa, one of Jupiter's Galilean moons and a key target in the search for habitable conditions in our solar system. See that black spot just to the left of the Great Red Spot? That's Europa's shadow cast onto Jupiter's cloud tops. Europa has a subsurface ocean beneath its icy crust, meaning it has the potential to support life, and is due to be studied in depth by the upcoming Europa Clipper mission. The Cassini mission at Saturn, for example, was able to see plumes of material erupting from the subsurface ocean of Moon Enceladus, and JWST scientists are hoping that the Space Telescope may be able to spot similar phenomena on Europa in future observations. Perhaps even more fascinating is a clear capture of Jupiter's rings, which can be seen in another of the NIRCam images. An image of Jupiter, its rings and moon Europa, captured by James Webb Space Telescope. Yes, Jupiter has rings, and the Webb telescope has managed to show these distinct features with remarkable clarity. We can also see moons Theia and Medes in the new Jupiter images. The Jupiter images in the narrow band filters were designed to provide nice images of the entire disk of the planet, says John Stansbury, NIRCam commissioning lead at the Space Telescope Science Institute. But the wealth of additional information about very faint objects in those images with approximately 1-minute exposures was absolutely a very pleasant surprise. James Webb Space Telescope's first full-color image, a deep view of space centered around galaxy cluster. The first image to be released by the James Webb Space Telescope is the deepest infrared image of the distant universe ever produced. Following in the footsteps footsteps of the Hubble Deep Field. The image has become known as Webb's first deep field. It shows galaxy cluster SMACS 723, and in the background, thousands of galaxies, including some of the faintest objects ever observed in the universe. The deep field was captured by one of the Webb telescope's instruments known as the near-infrared camera, and was produced using 12.5 hours worth of images captured at different wavelengths. Because Webb peered so far into space to capture the image, it was able to observe distant light that's been traveling across the cosmos for billions of years. As a result, galaxy cluster SMACS 723 appears here as it would have existed 4.6 billion years ago. This is one of the key aspects of Webb's science goals over the coming years. Astronomers are keen to observe further into deep space, and in doing so learn more about the early universe. Hubble Ultra Deep Field, the 3rd of June 2014. Virtually every point of light in this image is a galaxy, each composed of billions of stars. Teplitz and M. Rafalski, A. Kokomor, R. Windhorst, Z. Levy. Hubble Ultra Deep Field, the 3rd of June 2014. Another interesting aspect of the image is that it shows a phenomenon known as gravitational lensing in action. The combined mass of galaxy cluster SMAGS 723 is warping and magnifying the light from more distant galaxies behind it. This presents astronomers with a sort of cosmic magnifying glass, enabling them to observe distant objects in greater detail. It's also why some of the light from those distant galaxies seems curved and warped. Now astronomers will begin to analyze and learn more about these distant galaxies and the tiny structures seen within. Exoplanet WASP 96b. Transmission spectrum of exoplanet WASP 96b, captured by the James Webb Space Telescope. WASP 96b is a giant planet outside our solar system, known as an exoplanet. The planet is composed mainly of gas and is located just 1,150 light-years away. It's about half the mass of Jupiter, and it orbits its star every 3.4 Earth days. This is a transmission spectrum made by observing exoplanet WASP 96b. The spectrum was created by analyzing light that passed through the exoplanet's atmosphere as it orbited in front of its host star. Each of the 141 points on the graph shows the amount of a specific wavelength of light that's blocked by the exoplanet and absorbed by its atmosphere. Note the labeled peaks in the graph, indicating the presence of water vapor in WASP 96b's atmosphere. The heights of the peaks, along with other aspects of the spectrum, enabled astronomers to infer the temperature of the exoplanet to be about 1,350 degrees Celsius. This is the most detailed infrared exoplanet transmission spectrum ever produced, and an indication of just how much the Webb telescope could revolutionize the field of exoplanet study. Southern Ring Nebula. The Southern Ring Nebula, NGC 3132, one of the first images released by the James Webb Space Telescope. The Southern Ring Nebula is an object known as a planetary nebula, which is an expanding cloud of gas around a dying star. Their puffed-out, spherical appearance is what has given them the name planetary nebulae. Astronomers say that the dimmer star at the center of the image has been emitting loops of cosmic gas and dust into space in all directions. 2 JWST cameras were used to capture this image of the planetary nebula, which is located about 2,500 light-years away. The Southern Ring Nebula is visible to observers living in the southern hemisphere, as it can be found within the southern constellation of Vela. Stefans Quintet. This is a group of galaxies known as Stefans Quintet, one of the first images to be released by the James Webb Space Telescope. This is a group of galaxies known as Stefans Quintet, a compact galaxy group located 290 million light-years away in the constellation Pegasus, in the same patch of sky as the famous asterism known as the Great Square of Pegasus. This brand new image of Stefans Quintet contains over 150 million pixels and was produced using nearly 1,000 separate image files captured by the James Webb Space Telescope. It was captured using the telescope's near-infrared spectrograph and mid-infrared instrument. Webb's incredible image shows clusters of young stars and bursts of star birth across the galaxy group. While it may seem like the 5 separate galaxies in the group are gravitationally bound, actually only 4 of them are. The 5th and leftmost galaxy is NGC 7320, and it's actually much closer to Earth than the other 4 galaxies. NGC 7320 is 40 million light-years from Earth, while the others are about 290 million light-years away. One of the major takeaways from this image is that Webb can provide an incredible view of galaxies gravitationally interacting and merging, a key aspect of understanding how galaxies evolve and change over time. Stefans Quintet in a different light, a MIRI version of Stefans Quintet captured by the James Webb Space Telescope. Here's another Webb image of Stefans Quintet captured using just the MIRI instrument. The image was produced using one more MIRI filter than the NIRCam, MIRI composite image, enabling JWST to observe through more cosmic dust to reveal the secrets of galaxy mergers and galactic evolution. Image processing scientists working on the data at the Space Telescope Science Institute used all 3 MIRI filters and colors red, green, and blue to more clearly see distinct features of each galaxy and the shockwaves generated between the galaxies as they merge. Red indicates star-forming regions, distant early galaxies, and galaxies covered in dense cosmic dust. Blue shows stars or star clusters without dust, while more diffuse areas of blue reveal dust containing large amount of hydrocarbon molecules. Green and yellow represent more distant, earlier galaxies that are also rich in hydrocarbons. The Carina Nebula. The Carina Nebula, captured by the James Webb Space Telescope. The Carina Nebula is a glowing cosmic cloud found about 7,600 light-years away in the southern hemisphere constellation Carina. It's a common and well-known target for astronomers and astrophotographers, but none of them will ever have seen it like this. This image of the Carina Nebula, NGC 3324, was captured in infrared light by the JWST and shows peaks of glowing cosmic gas and dust about 7 light-years high. Ultraviolet radiation and streams of charged particles known as stellar winds are emanating from hot young stars within the nebula, sculpting and shaping the cavernous formations seen in this image. JWST's infrared vision is able to peer through the cosmic dust to see stellar nurseries and individual newborn stars that would normally be obscured in optical light. Images like these show just how much astronomers can learn from the Webb telescope about how stars are born, how they affect and influence their own cosmic neighborhood. This image was captured by Webb's near-infrared camera and mid-infrared instrument, an artist's impression of the James Webb Space Telescope. What I have seen moved me, as a scientist, as an engineer, and as a human being, says NASA Deputy Administrator Pam Melroy. NASA says it took 5 years to decide which targets the James Webb Space Telescope should observe and image first, and that the decision was a collaboration between NASA, ESA, CSA, and the Space Telescope Science Institute. Seeing JWST's first images, Hubble's famous 1995 image, The Pillars of Creation, Webb. These first images released by the James Webb Space Telescope are full-color images to showcase what the telescope can do, but JWST is also capturing spectroscopic data, which enables astronomers to gather information about their chosen target by analyzing light. And now that these first images have been captured and released to the public, the key scientific observations will begin. It's been a long journey for the James Webb Space Telescope and its scientific personnel, but we finally caught a tantalizing glimpse of just what it can do. We are about to enter a new era in observing and locking some of the biggest mysteries of the universe. Test in mid-May. One of the most recent James Webb Space Telescope test images released by NASA shows a view of stars and galaxies captured by JWST's Fine Guidance Sensor in mid-May 2022. The image was captured as part of a thermal stability test to see how well the Webb telescope can stay locked onto a target. While this is not a full-color image like those currently being released by the JWST team, it does reveal a few interesting elements, such as sharply defined diffraction spikes on the stars, which are a result of the telescope's 6-sided mirror segments. Looking beyond the stars, the bright blobs visible across the image are galaxies stretching far into deep space. This image was captured using 72 exposures over 32 hours, and, say NASA scientists, is one of the deepest images of the universe ever taken. JWST's image of the Large Magellanic Cloud. In May 2022, NASA released an image by the James Webb Space Telescope that shows an amazing view of the Large Magellanic Cloud, a satellite galaxy of the Milky Way. The image was captured with JWST's coldest instrument, the Mid-Infrared Instrument, or MIRI. Focusing on the star field of the Large Magellanic Cloud provided an opportunity for Webb scientists to test the telescope's imaging performance. A view of the Large Magellanic Cloud captured by Spitzer and by James Webb Space Telescope. NASA released a side-by-side pair of images showing how James Webb Space Telescope's capabilities compare to the Spitzer Space Telescope. The now-retired Spitzer Observatory captured high-res images of the universe in near and mid-infrared. Webb, with its significantly larger primary mirror and improved detectors, will allow us to see the infrared sky with improved clarity, enabling even more discoveries. A NASA statement said, after weeks of alignment, NASA finished focusing the James Webb Space Telescope's primary mirror on the 11th of March 2022, achieving a precision that exceeded the original goal and resulted in the image below. An image of star 2 mass J175544042 plus 6,551,277, released on the 16th of March 2022. The image was significant because it showed that each of JWST's 18 primary mirror segments, which produce the Space Telescope's iconic honeycomb mirror design, had been aligned correctly. Thanks for your support.